Hold up your hand and look at it for a second. The skin, the bones, the blood moving underneath. It feels like the most ordinary thing in the world. But almost every atom in that hand was forged inside a star that exploded and died long before the sun was ever born. You are not from here.
Not really.
The calcium in your teeth, the iron in your blood, the oxygen filling your lungs right now. None of it started on Earth. All of it was cooked in the heart of a dying star, scattered across the galaxy in an explosion brighter than a billion suns, and somehow billions of years later it became you. This is not poetry. This is chemistry. And once you understand how it works, you will never look at the night sky the same way again. Let's go back to the beginning. The real beginning. When the universe was young, it was almost unbelievably simple. After the Big Bang, there were really only two ingredients worth mentioning: hydrogen and helium. The lightest, plainest atoms there are. No carbon, no oxygen, no iron, no gold. The early universe was a thin fog of the simplest stuff imaginable, and nothing else. So here is the obvious question. If the early universe was just hydrogen and helium, where did everything else come from? Where did the carbon in your cells come from? The oxygen, the calcium, every heavier element that makes up your body and your planet and your entire world. The answer is stars. Stars are not just lights in the sky. Stars are factories. And to understand that, you have to understand what a star actually is. A star is a furnace held together by its own weight. Gravity crushes a giant ball of hydrogen inward with unimaginable force. The center gets so hot and so dense that the hydrogen atoms start slamming into each other and fusing together into helium. That process is called nuclear fusion, and it releases a staggering amount of energy. That energy is the sunlight on your face. Your sun has been quietly fusing hydrogen into helium for about 4.5 billion years, and it will keep doing it for billions more. But here is the part most people never learn. Fusion does not stop at helium. In a big enough star, once the hydrogen in the core runs low, gravity squeezes even harder, the core gets even hotter, and the star starts fusing helium into something heavier: carbon. The exact element your DNA, your skin, and every living thing on Earth is built around. There was a long-standing problem with this idea, though. The math said carbon should not be able to form easily. The steps just did not line up. In the 1950s, an astronomer named Fred Hoyle made a bold prediction. He argued that carbon could only form if it had a very specific, hidden property, a precise energy state that would let the reaction work. Almost no one believed him. But when physicists went and tested it in the lab, the property was there, exactly where Hoyle said it would be. Carbon could form in stars, after all. And you are standing here, made of carbon, because of it. Then, in 1957, 4 scientists published one of the most important papers in the history of astronomy. Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle laid out, step by step, how stars build up nearly all the elements heavier than helium, deep in their cores, over millions of years. The paper is so famous that scientists just call it by the author's initials. It showed something almost impossible to believe at the time. The periodic table you memorized in school was written inside dying stars. William Fowler later won the Nobel Prize for this work. So picture what is happening inside a massive star near the end of its life. It is like an onion. Hydrogen fusing in the outer layers. Helium fusing deeper in, then carbon, then oxygen, then heavier and heavier elements in shell after shell, each one burning hotter than the last as you move toward the center. And right at the heart of it all, the star starts making iron. This is where everything changes. Iron is special. Iron is the wall the star cannot climb. Fusing lighter elements gives a star energy, but fusing iron takes energy away instead of releasing it. The moment a giant star fills its core with iron, the furnace goes quiet. The outward push that held the star up for millions of years suddenly stops. And gravity, which has been waiting this entire time, wins. In less than a second, the core collapses. The outer layers of the star come crashing down, hit the dense core, and rebound in a shockwave of unbelievable violence. The star tears itself apart in an explosion called a supernova. For a few weeks, a single dying star can outshine an entire galaxy of hundreds of billions of stars. And in that explosion, something beautiful happens. The energy is so extreme that elements even heavier than iron get forged in an instant and blasted out into space.
The iron in your blood.
The calcium in your bones, all of it thrown across the galaxy in a cloud of glowing debris, drifting through the dark for millions of years. But what about the really heavy, really rare elements? What about gold? For a long time, supernovae were the best guess. But in 2017, scientists caught something extraordinary. Using an instrument called LIGO, they detected two neutron stars, the ultra-dense corpses of dead stars, spiraling into each other and colliding. And when telescopes around the world turned to look at the aftermath, they saw the chemical signature of newly created gold and platinum streaming out of the wreckage. So the gold in a wedding ring, the gold in your phone, may have been born in the collision of two dead stars, more violent than anything you can picture. Now slow down and let this settle, because here comes the twist. Every one of those scattered atoms, the carbon and oxygen and iron and calcium, drifted through space as part of an enormous cloud of gas and dust. And about 4.5 billion years ago, one of those clouds began to collapse under its own gravity. Most of it pulled together to form a new star, your sun. And the leftover scraps, the debris that did not make it into the sun, clumped together into planets. One of those planets was Earth. So the ground under your feet, the water in the oceans, the air you are breathing, and the atoms inside your own body were all part of that ancient cloud of stellar ash. You are not living near the leftovers of dead stars. You are made of them.
Literally.
Physically, atom by atom. The astronomer Carl Sagan put it in a way that millions of people have never forgotten. He said we are made of star stuff. People sometimes hear that and assume it is just a lovely metaphor, a nice thing to say. It is not a metaphor. It is a measurable, verifiable fact about the contents of your body. Take a slow breath right now. Feel your lungs fill. The oxygen molecules rushing in were forged in the core of a star that died before our sun existed. Put your hand on your chest and feel your heartbeat. The iron carrying oxygen through your blood in this exact moment was created in the final seconds of a supernova. You are not separate from the universe, watching it from the outside. You are the universe briefly arranged into something that can look up and wonder about itself. And here is the part that should genuinely stop you. Long before any of this was understood, an astronomer named Cecilia Payne-Gaposchkin made a discovery that almost nobody accepted at first. In 1925, studying starlight, she figured out that stars are made overwhelmingly of hydrogen. At the time, scientists were certain stars were made of roughly the same stuff as Earth. She was right and they were wrong, and her work became one of the first steps toward understanding what stars are and what they make. A young woman, looking at light, beginning to read the recipe of the cosmos. That light she studied is the same light you can see tonight. And every star up there is doing exactly what the stars before it did. Burning, building, eventually dying. Seeding the galaxy with the raw material for the next generation of stars, planets, and maybe somewhere, the next generation of curious creatures looking up and asking where they came from.
So look at your hand again.
It is not ordinary. It never was. It is a piece of the early universe, processed through the furnaces of stars, scattered by explosions across unimaginable distances, gathered back together over billions of years, and somehow assembled into a living thing that can read these words and understand its own origin. You are not from here. You are from everywhere the stars have ever been.